Maybe from there, let's get someone to pick up from there. Thank you, Isabella. Thank you so much for reminding us. You can mute yourself. Any other person? Any other person that can tell us, that can add on what Isabella said? Let's look at Isabella. You can lower your hand. Lower your hand and mute yourself. Derek, what do you think? What do you remember? Derek Mugisha, what do you remember about the previous lesson? Derek, you've run away. We shall never forget you. Once again, I sent in the notes of last time in our Google Classroom, and I also sent in an exercise. And the last time I checked, only 2 people had turned in the exercise, the assignment. I don't know whether others win or will not, but let us try to do that exercise by the end of today, so that we get to test ourselves. It is always important to do exercises or assignments. It's very important, because there we get to know what can we do if we are alone. If we are not in class with others, what can we do alone? We call it the ratio of 1 to 1. It is you and the exercise. So let us run the Google Classroom after this lesson. We do the exercise so that we can be in position to do the next exercise. Viking here is saying that carbon dioxide turns lime water milky. Okay. So we talked about the properties of carbon dioxide, as Isabella said. And again, we looked at the physical properties, where we said the gas is colorless, odorless, and tasteless, like the way she said all of them. Then we went on and talked about the chemical properties of carbon dioxide, whereby we looked at the reaction with lime water. What is the other name? What's the other name of lime water? Who can tell us? What is another name of lime water, or what is the chemical name of lime water? What did we say? Okay. Yes, Viking?
Good morning, teacher.
Good morning to you.
Calcium hydroxide.
Calcium hydroxide, thank you. Then we also looked at the reaction with air or with oxygen, and so on. So before we start, I just want us first remind ourselves of the lesson's objectives of today. So today we want to look at how we can explain the test for carbon dioxide in the lab or in the laboratory. So we want that by the end of this lesson, at least all of us should be able to explain that. To explain the test for carbon dioxide in the laboratory. Also be able to explain the chemical reactions of carbon dioxide, that is when it reacts with oxygen in air, lime water, we looked at it. And today we want to emphasize it to make sure that all of us are at the same page. And then reaction with sodium hydroxide at all conditions. And then also magnesium and metal. So we want to look at reaction with sodium hydroxide. We want to start with that. Okay. So but before that, who can take us through? Who can take us through the reaction of carbon dioxide? Who can take us through the reaction of carbon dioxide with lime water? What did we say about that? What did we say about that reaction? What really takes place? Anybody to share with us? You can write your equations or your answer somewhere and you share the screen. I can give you that opportunity. If you're willing to share with us your screen about what takes place with carbon dioxide when it reacts with lime water, You can raise up your hand so that I can give you time to prepare yourself. Just raise up your hand so that I can give you time to prepare yourself, so that you can share your screen of what takes place when carbon dioxide reacts with lime water. Now here we are making history. We are making history. Even after 50 years, we shall be able to come back and check how we used to perform. How we used to perform online. We shall have the evidence to show our grandchildren that this is how we did things, and this is how I used to contribute in my class. So yes, Isabella. So Isabella, can I give you time, or you already have what to share with us?
I have.
You have what to share
Carbon
with us?
dioxide turns yes.
First wait. With this explanation, we require to see some equations. So do you have the equations already?
Yes.
Do you know how to share the screen?
Carbon dioxide. Yes.
Isabella, do you know how to share the screen?
Yes.
So should I give you the permission to do so?
Yes.
Okay. So I'm going to stop sharing so that you can also start sharing. Okay, you can now share the screen. Remember, we are sharing that work that you want to show us. Winnie, video off. So members, Isabella is sharing her screen.
Carbon dioxide turns lime water milky due to the formation of insoluble calcium carbonate.
Okay, but Isabella, your screen is... I thought you had written something on the paper.
I'm going to write.
Now, what you're going to do, it is like it take us longer. So for me, I'm advising that you write the answers, or the answer to that question on a piece of paper, then you take a pic of it, then you share that pic. Clear?
Okay. But I'm using a laptop.
You're using a laptop, eh? Okay, fine. Maybe to save time, I thought you were using a phone. To save time, you just tell us. We shall go with what you tell us. Thank you.
Carbon dioxide turns lime water milky due to the formation of insoluble calcium carbonate. However, when excess carbon dioxide is bubbled through the solution of lime water, the white precipitates dissolve, making the solution to appear clear.
Okay. So we have an equation. We have an equation of calcium, of carbon dioxide. Carbon dioxide gas reacting with calcium hydroxide, the one we call lime water. So this is calcium hydroxide, and it is aqueous, and we are getting a white precipitate of calcium carbonate, a white precipitate of calcium carbonate, then and water. And water. Is it balanced? According to the question I have on the screen, is it balanced, or we need to balance it? Someone can say yes or no. You can use the chat. Let's use the chat. Say yes or no. Yes, Agnes. Agnes?
No, it isn't balancing.
So what should we do? You can tell me and I write. Agnes, you can tell me what I should write.
It's not balancing.
Yes. Can you help me and we balance it together?
Yes, I'll put a 2 on calcium carbonate.
I put a 2 on calcium carbonate.
Yes.
That is it, eh?
And we put also a 3 on carbon dioxide.
A 3 on carbon dioxide. Yes. Agnes, are you there?
Yes.
Is that on?
Yes.
Yes, please. So Agnes, according to what you were telling us, I think we have missed something, because if you put a 3 here, it means that we have 3 carbon atoms. Here this side we have only 2, to be 2 times 1, which gives us 2. So that would be wrong. That would be wrong. Let's have the last person. We need always do these things very fast so that we can catch up with time. Anybody else can raise up the hand and we balance the equation together very fast. Yes, Baraka.
Teacher, it is balanced.
It is balanced.
Yes.
Thank you. So Baraka is saying that it's balanced. Let's check it out. We have 1 carbon atom here. Then here we also have 1. Here we have 2 oxygen atoms. So here we have 2 for oxygen. And also we have here 2 times this 1 times this 1 oxygen atom, which gives us 2 plus 2, that is 4. And here we also have 3 oxygen atoms plus this 1 here, which gives us also 4. Meaning that oxygen atoms are balanced. Calcium, we have 1. Calcium also have 1. And then hydrogen, we have 2 times this 1, which gives us 2. Then this side we have 2 on in water. So the equation is balanced. Thank you, Baraka. So the equation was already balanced automatically. Okay. So what we are having now, is when we have less carbon dioxide. Is when we have less carbon dioxide, and we say that this is a white precipitate. A white precipitate. It is a white precipitate. So what we have formed here is a white precipitate. This one here. This is the milky substance that is formed. And then again we said in excess. So here we can say limited. We can say limited carbon dioxide. And then in excess carbon dioxide, when it is in excess, we shall have what we have formed, our precipitate, that is calcium carbonate, which is a solid. Can someone mute himself? Or can you mute yourself? Then plus water. Then we add excess carbon dioxide. We add excess carbon dioxide, and here we shall get the clear solution or the colorless solution, which is calcium hydrogen carbonate. Calcium hydrogen carbonate, which is aqueous. So this is what we looked at last time, and I hope it is also balanced. It is also automatically balanced. Nansobuga, I'm unable to respond to your question because I've always answered that. So today, no. Sorry about it. So this is what really happened. So we are saying that this is the colorless solution. Colorless solution. This is the colorless solution. So basically, this is what we looked at last time, and we're just reminding ourselves for what we looked at. So today I want us to look at reaction of carbon dioxide with sodium hydroxide, and we shall also have this in two. We shall also have two conditions. One, we shall have when we have less carbon dioxide. So let's see what we get when we have less carbon dioxide. Yes, this is OBJ, prods. Yes, please. I see your hand up. Unmute. Okay, Agnes.
Mr. I was asking whether limited and less aren't the same.
They are the same. We just try to give alternative words. If you don't use less, you can say limited.
Okay, Mr.
All right. So maybe here we can also put the word we can put the word limited as well. We can say limited carbon dioxide. Okay, so what happens is what happens with calcium hydroxide. So we shall have sodium hydroxide. Reacting, it is aqueous. Reacting with carbon dioxide gas. Then we shall form sodium carbonate. Which is a colorless solution, and of course water and water. Okay, so this is when we have less carbon dioxide, or when we have limited supply of carbon dioxide. Then in excess it is a continuation of this. So from here we go to excess. From here we can say excess carbon dioxide. So we shall come from here, meaning that to what we have formed here, we add excess carbon dioxide to our product. So we shall have our sodium carbonate formed. Sodium carbonate formed. Then we add their water, which is already added the other side. Then we shall form, we add their excess carbon dioxide because we are having excess of it. And we shall also form a clear solution. We shall form a clear. So we shall form a white precipitate. So we shall form sodium hydrogen carbonate. Sodium hydrogen carbonate, and this is a white precipitate. That is a white precipitate. It is the only hydrogen carbonate that is a precipitate for sodium. Okay. So here we are saying we are forming a white precipitate. I hope we are clear and we are together. Don't allow to be left behind. Yes, Conrad.
Excuse me, sir.
Yes, please.
I've not understood I've come late and I've not understood what you were talking about. Please, may you repeat?
I wish to repeat, but we are against time, so and it would also be unfair those ones who came in early, because you have come almost 30 minutes late. So I beg that you wait for the recording of this lesson.
Okay.
To cover the lost minutes, so that you catch up from the recording. If you don't understand, then you reach me. Thank you.
Okay, sir.
Yes, Agnes.
Excuse me, mister. What shall we
Yes, please.
form? What are we forming in the first one when carbon dioxide is limited?
What we form, we are forming this. Maybe I can circle using a different color. We are forming this. We are forming sodium carbonate. And sodium carbonate, maybe it's because I didn't write the color here. Sodium carbonate, it is colorless. So we are forming a colorless solution. We are forming a colorless solution. And water. Is it clear?
Okay, mister.
All right. So remember, this is what we do. This is what we form. In less carbon dioxide, we shall form a colorless solution, that is of sodium carbonate. Then in excess, you can see how I'm adding my excess. My excess, I'm just adding to what we form from when we have less. In other words, even though you had excess, you would first form sodium carbonate, which will later turn to a white precipitate. So I want to go back and check. We want to check our equations if they are balanced. Do you think they are balanced? Anybody help us balance this equation? The first one, let's start with this one. By show of hands, you can raise up the hand and I'll help you write. Yes, Joan.
The first equation is not balanced.
Sorry? Joan, I'm not getting you. Joan?
The first equation is not balanced.
Okay, how can we balance it? You can tell me, then I write for you. It seems Joanne, your network is
Should
not okay.
put at
Joanne, you're not clear. Sorry, I'm going to mute you. Let's hear from Stella. Stella, you can unmute yourself. Stella?
Yes, teacher. The first equation is not balanced, and to
Okay,
balance
now what
it,
should we do?
we put a 2 at the beginning of sodium hydroxide in the first part of the equation.
So we put a 2 here.
That's all.
That's all. Thank you. Let's check it out. So here we have 2 sodium atoms. Here we have 2. Then oxygen we shall have 2 times 1. This one here we get 2. Then plus these 2, which give us 4. This side for oxygen we are having 3 plus this one, which give us 4 also. Then hydrogen we have 2 times this one. Then here we have 2 hydrogen atoms. So all the atoms are balanced. So we say the equation is balanced. Then the second one. The second one. Second one, let's have yes, Sheena. Same as the ladies are taking over. Sheena, you can unmute. Same as Sheena, you are unable to talk. We have a representative from the gentleman. Yes, Lara.
Teacher, it is not balanced.
So what should we do?
We add 2 in front of sodium hydrogen carbonate.
So we added 2 here. That's all. Baraka, is
Yes.
that one? Okay, thank you. So thank you for your answers. Someone is saying that she has not understood the first equation. The first equation, it is when we have less carbon dioxide. That is when sodium hydroxide is reacting with carbon dioxide, but in less quantity. And then there we form let me first remove what I had put. We form sodium carbonate, and we say it is a colorless solution. Then in excess, we shall form a white precipitate. So this is how the question can be set. This is how a question can be set on this number, or on this part. We can say, write the equations. They put the equation, the S in the bracket, write equations, and the observations when sodium hydroxide reacts with carbon dioxide. Reacts with carbon dioxide. I'm just avoiding writing the word to save time. In excess. So when they say in excess, you have to write these 2 equations, because at times when they put this S in the brackets, it means that you're likely to have more than 1 equation. So you have to put the 2. You have to write the 2 equations. one for limited, another one for excess. Okay, then observation, you will say that we form a colorless solution which turns to a white precipitate in excess carbon dioxide. A white precipitate in excess carbon dioxide. Okay. So let's see what we have. So when carbon dioxide is bubbled through a solution of fairly concentrated sodium hydroxide, the solution remains clear. That is when we say it turns colorless due to the formation of a soluble sodium carbonate. So whenever we are marking this kind of a number, these are marking points. So I would give you a half a mark here, also a half mark here. Then an equation, the one we have looked at, I'll give you another 1.5 marks. So already here on the same number, we have 2.5 marks. And remember, this is when it is in less supply, or when it is less. Then when it is excess, we can say that, however, when excess carbon dioxide is bubbled through the above solution, the white precipitates appear due to the formation of insoluble. The white precipitates appear due to the formation of insoluble sodium hydrogen carbonate. So mentioning that there is the formation of a white precipitate, you get a half a mark. Also another half a mark, indicating that the sodium hydrogen carbonate formed is insoluble. Then also giving the equation. Also giving the equation, also give this one gives you half and a half marks. So you find that we have 0.5 marks on this number. The maximum you can score are 5 marks. So you need to know what happens when there is less carbon dioxide. You need to know the equation as well as the observation. I hope I'm clear there. We move on. Someone said that I'm too speedy. It is because I first explained the whole thing. Now I'm just showing you what is in the notes. That's why I had to first take time on explaining at first. Okay, so we continue. We look at another reaction. Someone is asking, teacher, why is it soluble in excess and insoluble in limited? It is soluble in excess. I don't know which one you mean. If you mean sodium carbonate, if you need sodium hydroxide, then it is not soluble in excess. It is insoluble in excess. It is because of the nature of the compound being formed. Remember, when we are looking at salts, we had the soluble ones and the ones which are not soluble. So once we form an insoluble carbonate, then it will not dissolve. Someone else, you are saying that I send the work to the classroom. I've already sent the work there. Then Selma is asking to let her copy the notes. There is no need of copying the notes right now, because I'm going to send them in your classroom and you'll be able to have your time to copy the other notes. So when we come to the reaction of carbon dioxide with magnesium, magnesium is one of the metals that produces a lot of heat. When it is heated, it will produce a lot of heat, and it is one of the metals that reacts with many nonmetals. For example, it can react with nitrogen. We shall look at that. Nitrogen. It can also react with carbon dioxide. One of the properties of carbon dioxide, we say that it does not support burning. So it is not supposed to be burning with with magnesium. But due to the heat produced by magnesium when it is heated, it is strong enough to break the bonds within carbon dioxide. to get this oxygen which is here. Remember, the structure of carbon dioxide is like this. That's the structure of carbon dioxide. So magnesium produces enough heat to break these bonds so that it can get off the oxygen and it reacts with it. So when we have magnesium, when we have magnesium reacting with carbon dioxide, gas. And once again, not every metal can react with carbon dioxide, it's only magnesium in this case. So here we shall form magnesium oxide, and carbon, and carbon. So it is going to take away this oxygen from carbon dioxide. It is going to remove this carbon dioxide, oxygen, then it takes it. And when it takes that, it becomes magnesium oxide. It is the same as having magnesium reacting with oxygen. Then we form magnesium oxide. That happens when magnesium takes up this oxygen. Then when carbon dioxide loses the oxygen, it becomes carbon. And again, this is if you had read the observation, this is a white solid. This is a white solid, and then this one is a black. These are black particles. Particles. At times they call them specks. At times we can call them specks, or at times we can call them solids also. So you choose one of the three words. So if they ask you the observation, you would say magnesium continues to burn. Magnesium continues to burn for some time to form a white solid and black particles. Any questions on that? And again, if a number came in paper 1 where we have on objectives, we shall do those papers, I think, when we reach senior 3. They can ask you which of the following metals react with carbon dioxide. Then they put for you like zinc. They put for you like they can put zinc. They can put for you zinc. A, zinc. Then B, they can put for you lead. Then C, they can put for you maybe aluminium. Then D, they can put for you magnesium. So our answer would be magnesium. It is the one that will be able to react with carbon dioxide. So we say that when a piece of burning magnesium, remember I said it has to be burning, so heat must be applied so that can be produced, is lowered into a gas jar of carbon dioxide, it continues to burn. This is a half a mark, forming black specks, or what we call black particles or black solids of carbon, and also white solids, solids of magnesium oxide. Then you give the equation, and the equation, it will take 1.5 marks. That is if it is well written and also well balanced. Okay, I'm going to request Mr. Charles, if you are online, please share the code, the link to the Google Classroom, or the code to the Google Classroom. So that is with the reaction of magnesium with carbon dioxide. Any questions on that? Okay, we continue. With potassium hydroxide, we shall go through the same thing, only that here our observations change. We shall have less and also excess carbon dioxide. So we say that when carbon dioxide gas is bubbled through a solution of potassium hydroxide, there is no observable change as the products formed are all soluble. So the products we are forming, all of them are colorless, or we can say all of them are colorless solutions. So we shall not see any change. So when we have less carbon dioxide, this is when we have less. This is when it is in less quantity. So here we have less. I can say that we are forming this potassium carbonate, and potassium carbonate is also colorless, so we can say colorless solution, or we can call it clear solution. We can call it clear solution. So the first scenario, we have less carbon dioxide and we are forming a colorless solution or a clear solution. Then secondly, when we have excess, so this is when we have excess. This is when we have excess carbon dioxide, and again we are forming a colorless solution. So we shouldn't confuse this. The reaction of carbon dioxide with sodium hydroxide with potassium hydroxide. Remember, we said with sodium hydroxide we shall form a colorless solution at first. That is when we have less carbon dioxide. Then we shall form a white precipitate when we have excess carbon dioxide. And for potassium hydroxide, in a different case, we are having no observable change. We are not having any change. All of them all the products that are formed, all of them are colorless. Are we all on the same page? If you have any questions, you can raise up the hand. So by seeing no hand means that everything is okay. All right. Yes, Joan. Joan.
Yes.
Joan, your network is not clear. Do you mind using the chat? Joan, I wish that you use the chat.
To ask reaction with magnesium. Yes, teacher. I wanted to.
Yes, go on. Joan, her network is not okay. Let's hear from Techno Mobile. Techno Mobile Limited. Techno Mobile. Maybe I can rename him. Can call him unknown. Yes, unknown, you can talk to us. We can hear from yes, Shina.
Excuse me, teacher.
Yes.
When in less carbon dioxide, it is colorless. Even in excess carbon dioxide, it is colorless. Why?
Yes, because we are forming what we are forming. In the first case, we are forming potassium carbonate, which is a colorless solution. And again, in the second case, when we have excess carbon dioxide, we are forming potassium hydrogen carbonate, which also happens to be colorless. And that's what we see. And when you're writing observations, you write what you see. So that is how we come to say that there is no observable change. You get it now? Shina, you can mute yourself. Someone is saying that Joan is saying that the reaction with magnesium, the equation wasn't balanced. Maybe we can cross-check and see. But I think it was balanced. Maybe if you didn't see it. Joan, you're saying that the equation was not balanced, but here I'm seeing a 2 and also a 2 here. I'm seeing a 1 and also a 1 here, and a 2 here, and also a 2 here. So Joan, the equation was balanced. It is balanced. Yes, Maria? Hey, Maria, your hand has disappeared. So let's look at uses of carbon dioxide. Someone has sent me a message, Bulamu. I really don't understand what you said. I don't know this language for sure. Yes, Maria?
I was saying on the uses of carbon dioxide, is it?
Yes.
I was saying carbon dioxide is used in fire extinguishers.
Carbon dioxide is used in fire extinguishers. Thank you. Agnes?
It is used in the preservation of drinks.
It is used in the preservation of drinks. Thank you. Barak?
It is used in baking.
It is used in baking. Is it used in baking, or it is used to make something that is used in baking? I think it is used to make something that they use in baking, not itself being used. Yes, Maria, once again.
It is used by plants. It is used by plants to make food.
To make food. Okay, thank you. Then we have Sulaina.
Solid carbon dioxide, dry ice is used as a refrigerating agent for perishable goods.
It is used as a refrigerating agent for perishable goods. Thank you. Namakula.
Carbon dioxide is used in inflating life jackets.
Inflating life jackets. Thank you. Okay. Christine, you are not in the right class. You are in the wrong class. This is senior 2. So, uses of carbon dioxide. 1. It is used as a fire extinguisher. In fire extinguisher. Not as. It is used in fire extinguisher because it doesn't support burning and it's better than air. Then secondly, it is used in the manufacture of effervescent drinks, and this is because of the solution of a gas in water has a pleasant taste. So here we are giving an example like the taste of soda. Then carbon dioxide is used in the manufacture of baking powder, So this is where the baking comes in. So carbon dioxide is used to make baking powder that is used in bakery. Then, like someone said, solid carbon dioxide or dry ice is used as a refrigerating agent for perishable goods. Then solid carbon dioxide, once again, or dry ice, is fired into the cloud where it cools to form rain. And we say this happens in places where there is unreliable rain. That is where they don't receive enough rain. So how do this for carbon dioxide? One, we say that when carbon dioxide gas is passed through a solution of calcium hydroxide, we looked at this reaction before, or what we call lime water, the solution becomes milky. And this is due to the formation of calcium carbonate, which is insoluble. And we have the equation. So what we are having right now on the screen is how we test for carbon dioxide gas in the lab. What we use? We use calcium hydroxide, or what we call lime water, which becomes milky. Then you also give the equation. If they ask you what is that milky substance that is formed, then you say it is insoluble calcium. It is insoluble calcium carbonate. Okay. So I'm now going to request for some questions. So that was our lesson of today. This was our lesson. Remember, we are sponsored by Edify Uganda, connected by Christian Schools Owners Association, and implemented by ITAO. I'm seeing Manchester United raising up the hand. What has happened again? Okay, any questions? Only two, and we call it a day. Yes, Elizabeth, can you switch off the video?
Excuse me, teacher.
Yes, please.
Can I get the work from Google?
Yes, you will get the work. Okay. This person, the name is Had. She is called Instagram.
Why are delayed?
Sorry?
I was saying this Zoom, like it's sponsored by Christian schools, because I can see it's also live on YouTube.
Exactly.
Okay.
So Edgar, if you have a question you can ask, and also give us a closing prayer. Edgar, unmute and also give us a closing prayer. Same as Edgar is unable to talk, let's have Joanita can give us a closing prayer. Joanita, I've seen your message.
Yes.
Maybe you send me a message on WhatsApp, then we shall see what we can do.
I don't have your number, teacher.
The number, I'm going to share it.
Okay. Thank you. Okay, let's pray. Oh God, we thank you for this day. We thank you for the life of our teacher. We thank you for the life of our parents. Most of all, we thank you that you've enabled us to have this lesson. Please send us your Holy Spirit to help us remember everything we have learned. In Jesus' name we pray and believe. Amen.
Amen. So the number is there. Joanne, the number is there.
Okay, sir. It's disappeared again.
Okay. So thank you so much, and I wish you